Okay. Good afternoon and good evening, and also good morning, everyone. And thank you for attending the webinar. It's also the first webinar in the new year. And today we are very glad to have Dr. Meng Li from Shanghai Jiao Tong University. And Dr. Meng Li was awarded the Leontief Memorial Prize in 2025, and her research focuses on input output modeling, global supply value chain, and also the socio-economic, environment, and climate impacts. Today, Meng will give a talk about measuring global value chains with different index and methods. And the webinar will be recorded today, and the link of the record will be available in the IIOA website. The floor will be given to Meng, and I will share the screen for her.
Thank you so much.
Okay.
And good evening. Thank you. Good evening, everyone, or good morning, afternoon, depending where you are in the world. And first, thank you very much to Professor Jing Meng for inviting me. And it's a real pleasure to join this IIOA webinar, especially it's the first one in 2026. And it's also great to have the chance to share some ideas and with the colleagues in our community. And the study of global value chains is quite a exciting field, not only because it's relevance to describe the real world and how the world economy works, but also thanks to many contributions from some scholars in this field over the years. And today my talk won't only focus on my own original research. Instead, I'd like to take a step back and review some of the main indicators and methods used in measuring the global value chains developed by other researchers and scholars. And my hope is that these webinar will be useful, and whether you're new to the field or have been in this field for a long time, and it could spark some interesting discussion. And thank you all for being here. And I'm going to start my talk today. So this talk is going to be about in three parts, and the first part is going to be the rise of global value chains. And if we see, if you ask me, please next page. If you ask me what is a perfect example of global value chains, I would say like an iPhone would be a good example because um in its 2023 report, we find that Apple's supply chains have over 700 manufacturing locations and 28 countries and about 200 supplier companies, and is truly an globalized company. But also, if we see some other next page, please. If we see some other industries, we could see that GVCs are actually everywhere, including some traditional industries like food and some traditional industries like metals and gold mining, but also including some newly emerging industries like semiconductor supply chains, ICTs, as well as many other industries. The next page, please. And if we see the past few, like 5 centuries, we could see a history of trade and globalization. And in the 15th century, we have the age of discovery. And in the 18th century, we have the Industrial Revolution and trade, the rise of trade. And now we could see that there is a new trend, that is the rise of GVCs. And this new and ongoing wave of globalization has been international trade growing faster than ever before, and today the sum of exports and imports across nations amounts to more than 50% of the value of the total gross output. We could see that from the Penworld table statistics. So what are the GVCs? A global value chain is actually a production process where the various stages from conception and design to production and then end use are located in at least two different countries. And economically, these represents a shift from trade in final goods and to trade in intermediate goods, services, and tasks. So this unbundling of production allows for a final international division of labor, where countries specialize in specific tasks rather than the entire industries. So this phenomenon is also referred to as international production fragmentation, vertical specialization, or trade in tasks. So next page, please. So we have known that globalization or the rise of GVCs have contributed a lot to the world economy and served as a source of growth, economic growth. We can see that from this plot, the average annual change in GDP per capita is highly related to the annual change in trade and is highly correlated, but also the emergence of the emerging of the global value chains has also brought some new challenges to the world economy and to how we understand the world economics. Professor Jing, please next page. So here we are going to name a few challenges, and the first one is going to be the Leontief paradox. From the traditional trade model, that is the HO model, we can predict that countries will export goods intensive in their abundant factor, so that the US, if the traditional model was actually true, the US, as the most capital-rich country in the 1950s, it should export capital-intensive goods. But actually, we had the Leontief puzzle, and researchers found that US exported more in labor-intensive goods than import competing goods. So these contradicts the HO predictions. And from these paradox, we knew that production structure can be actually more complex than assumed by the classic model. And there is also another challenge, that is the Chinese ICT export puzzle. And from the traditional trade theory, based on comparative advantage, China as a labor-abundant country should specialize in labor-intensive goods. However, since the early 2000s, China has become the world's largest exporter of ICT goods, including computers, smartphones, telecom equipment, and these goods are typically considered capital and technology intensive. So why and how can China dominate exports in sectors where it seemingly lacks comparative advantage? So simply using export data could sometimes be actually misleading. So this is the second challenge for us. So here raises some new questions for economists to answer. That is, we should develop some new indicators to accurately measure trade and describe trade patterns when production becomes increasingly complex. For instance, what determines a country, industry, firm's position within a chain, and how to measure its upstreamness, its downstreamness, and how long is the value chain, and how many participants, how many countries are involved in the value chains, and then how are the gains from trade are distributed among the many actors in the chain. There is also some other problems to answer and to address. Next page, please. So here is also some other problems like the double counting problem. We see that the gross trade statistics can be misleading sometimes, as traditional trade statistics record the gross value of goods and services each time they cross a border. For example, if Korea produced $100 of semiconductor and exported that to Malaysia for assembly, and Malaysia module is exported to China, and then the iPhone is exported from China to the US. And during this production process, the value of the original semiconductor is counted in the gross exports of 3 different countries. So it inflates the trade volumes and distorts the trade balances. A significant discrepancy between gross trade flows and national account statistics, which are measured in value-added terms, rises during this process. So researchers should solve the double counting problem during in the GVC era. So to answer all these questions, previous researchers and scholars have developed a set of indicators to measure the global value chains. For instance, next page, please. Here is a simplified GVC from upstream to the downstream, and the most upstream is R&D, which are which have high value-added rate, and then the manufacturing or fabrication stages, which have relatively lower value-added rate, and finally the downstream parts, which are like marketing and distribution, which also have high value-added rate. And how to measure the upstreamness, downstreamness, and the length of these simplified GVC, and some scholars have provided answers to this question. And the first one is going to be the upstreamness and downstreamness indicators developed by Paul and Tris. And in 2012, their motivation was to answer these questions. Are countries specializing in relatively upstream or downstream stages of the global production process? And can understanding upstreamness or downstreamness help us to answer the Leontief paradox? So in their paper, they developed the upstreamness and downstreamness indicators. Next page, please. So what is upstreamness or downstreamness? The upstreamness measures the average distance of an industry's output from the final use. And an industry that's more upstream, if its output is mainly used as intermediate inputs by other industries, not directly by the end users, for example, petrochemicals, aluminum, iron, and many other like coals. And on the other hand, an industry is more downstream if most of its output goes directly to final demand, for instance, automobiles, furniture, footwear, cloth. And they developed two approaches to measure industry upstreamness, which are involved in distinct ways but actually equivalent. And here is the first one. We could see that this is actually this is quite similar to the Leontief model, where Y is actually the gross output, and F is actually the final demand, and Z is actually the intermediate demand. And they traces how the gross output is composed of different final demand and how of different final demand and intermediate demand, and how these intermediate demand can be traced back to the to the final demand. And please next page. And here, so after tracing the gross outputs to the final demand, they developed these indicators. So the weighted average position of an industry's output in the value chain can be obtained by multiplying each of the terms by the distance from final use plus 1 and dividing by y. So here for this portion of final demand, it is one step from end users, and for these portions, these are actually two steps from end users, and these are three steps from end users, and then four steps, and blah blah blah. So using these equations, they measured the upstreamness of each product, and these can be applied on each country and each sector. Next page, please. So they applied this to the US input-output table, and they find that the relatively skill abundance in the US are correlated with a propensity to export in relatively more downstream industries. For instance, like automobiles, footwear, and light truck and utility vehicle, these are like more downstream, and there are some upstream sectors like aluminum, petrochemical. So the measure of upstreamness ranges from a minimum of 1 and to about 3. So they have developed the indicator of upstreamness and downstreamness, and at the same time, Bailey developed upstreamness and downstreamness at the same time. So they're trying to answer these questions. has production become more vertically fragmented over time? How long are production chains on average? And what determines the number of production stages? And to answer these questions, they have developed their own measurements. Next page, please. And so they first developed the downstreamness indicator, which is the number of embedded production stages. And here N reflects how many stages on average the product of I, that is the average number of stages embedded in good I. So it is measured as a weighted average number of producers involved sequentially in the production of I. That is to produce this pen, how many producers have involved in the production chain. So this is measured in this way. And on the other hand, they have also measured the upstreamness, which is on the next page. So the upstreamness is actually measured as the distance to final demand, where N reflects the number of stages before obtaining good I. The alternative measure, downstreamness, reflects the number of production stages between this good I and the final demand, that is between this and the end user. And it is measured also recursively using this method. And next page, please. So they also applied these two indicators to the US economy, and they calculated the weighted average number of production stages, and they found that from 1950s to 2000, the average number of production stages have been decreased during this time. That is to say that the upstreamness and downstreamness have all been reduced during this time. So next page, please. I will skip this page because these two pages are actually upstreamness and downstreamness measures. And they also use these two metrics to identify the largest values index in N, that is to say the most downstream sectors, and the largest values in D, which are the most upstream sectors, and which are quite in line with our intuition that copper ores, oil and gas, iron, they are upstream sectors, and meat packing, like truck, motor vehicles, these are the downstream sectors, which are more closely related to end users. So next page, please. And after all these indicators, we have also, I see Disenbach here in this webinar, and we have another very important paper that measures the average propagation length. When linkages between different industries are studied from the perspective production chains, sequencing is also important. So both the strength of the linkages and the distance between industries are relevant. And distance here in Eric's paper is measured by the average propagation length, which is defined as the average number of steps it takes a stimulus in one country, one industry to propagate and affect another industry. And so taking the backward-looking approach, the APL measures the average number of steps it takes a final demand increase in hotels and restaurants to propagate throughout the production process and affect the output value in the agriculture. And on the other hand, in the forward-looking approach, it measures the average number of steps it takes a cost push in agriculture to affect the output value of hotels and restaurants. And luckily or fortunately, the one advantage of APL is that both approaches yield the same answer. So next page, please. And here is the backward-looking way, and on the next few pages are the forward-looking way. I will skip these details, and then next page. Yeah, and we can see that the APLs are calculated from the input-output table from 6 countries, and here is the distance between the agriculture sectors, energy sectors, and the columns are the sectors, and the rows are also the sectors. And here the numbers means the APLs between these sectors. That is the length between them. So from these, we can see another indicator, which is also a complementary to the traditional, like the linkage indicator. And next page, please. And after all these very important studies, there's also some newly emerging indicators, which is like passing through frequency developed by Satoshi and Hanaka. Of course, length is actually important, which describes how many steps do we need to reach the final demand, to reach the factory inputs, for one industry to reach another, but also passing through frequency is also important. These represents the average number of times a particular supply chain passes through a target sector in a closed production system. And here's how they developed these indicator in the next few pages. And I will also skip their details. And if you're interested, you could look at their paper in ESR. And then we have also another types of research that traces or decomposes the input-output model, which is the KWW in 2024 on AER. And in their paper, they are trying to decompose the production into different GVC routes like pure domestic, traditional trade, and simple GVCs and complex GVCs. And next page, please. And in their paper, they still start from the traditional input-output model, and then they traces how values or final demand flows in the global value chain system using the backward way or the forward-looking way. I will also skip the next few pages and directly talk about the results. Here is the forward-looking way, and then we have their method can also be applied to measure the average production length between primary inputs to final products. And in their paper, they define the average propagation length as the average times that value added created by production factors is employed in a country's sector, and how many times it has been counted as gross output in the whole economy, which is quite similar to the example we talked about, the Korean semiconductor. And next page, please. And here is some the total production length, how it can be decomposed into different parts, although some of these parts are not actually addable. Next page, please. And they measured the GVC participation rate, and we can find that from the backward and forward approach, and from both approach, the GVC participation rate have been increased during the past 3 decades. And also, next page, please. They have measured these for different countries based on the OECD or ADB table, and showed the GVC participation rate have been increased all the time. And on the next page, there is a figure and showed that they compare the GVC length from the start year and the end year. And here, if the point falls here, it means that the GVC has been lengthened during this time. And we could see that from 2003 to 2018, most of the GVCs have lengthened during this time. But now, like during the COVID year, it's shortened or quite stable. And next page, please. And all these measures and indicators are actually very useful and very meaningful. And here is one question that I studied in my research. That is, can we use another method to measure all these indicators in one unified framework? That is, to answer these questions, I developed the probability-based measurements. Next page, please. So our length, upstreamness, downstreamness, passing through frequencies, participation, rates are actually the same things. And if we are not using these two strong words, are these indicators to some extent equivalent? Or can these GBC measures indicators be expressed in the same framework? And to answer these questions, we still start from the input-output model. This is the Leontief demand pool model, and this is the Gauss input-driven model. And on the next few pages, I'm trying to show that the input-output model is actually equivalent to the Markov chain. In the Markov chain, the output is going to be at the next production stage. It's solely dependent on its current status. It is actually equivalent to the input-output model. And then we are going to see that it's not only a Markov chain, but also actually an absorbing Markov chain, because when the output reaches the final product, it is consumed by the end users, absorbed, and never enters the production process again. So next page, please. So, so the classic input-output model can be viewed from a probability perspective. So giving an absorbing Markov chain with U transient states and V absorbing states. And we can see these are actually the intermediate supplies, and these are the final demand. And we can see that we can trace how the products flows in the Markov chain. And on the next page, we're going to see that a classic input-output model can also be expressed as an absorbing Markov chain. And one paper by Fei in 2010 has talked about this issue. And we can see that these, on the left side, this is the input-output model, like the Leontief model and the Gauss model. And here on the right-hand side, we show that we can use the absorbing Markov chain to trace where the value added goes to and where the value added originates. And this expression is exactly what we have seen in the input-output model. Next page, please. And in my original study, I was not trying to capture the length, like upstreamness and downstreamness. I was originally trying to capture the transmission of risks. So I added one module to the absorbing Markov chain. That is the Markov reward process, which is an extension of the basic Markov process, where each state in the process is associated with a reward or risk. So the cumulative reward risk over time, like the expected return or expected loss, can offer a comprehensive measure of the process. And if we are using some like reward or risk matrix, we can measure the risks in the Markov chain. And if you're using the identity matrix instead of the risk matrix, then we are tracing the upstreamness and production length. So from the above few pages, we show that we can use an absorbing Markov chain with rewards for risks in GVCs, and we can use these to trace how products goes in the production system and how risks flows in the production system, and also how the upstreamness and downstreamness and length operates in this system. Next page, please. And using these framework, we traces the risks or lengths in the input-output model in several aspects. The first, we measure the one-dimension risk, that is the steps for each steady state before absorption. We can see that here are the transient states and here are the absorbing states, and these are the traditional day matrix, and here are the traditional final demand matrix, and this is equivalent to the IO model. And here is the measurement, the indicators that we developed, we can see that here gamma is the risk discount index. We can make it 0 to 1. If it is 1, which means the risk fully accumulates in the global supply chain. And also, if we are measuring the upstreamness or downstreamness or the length, we need to make it 1. And here the Q matrix is actually the B from the Gauss model, and here R is the risk matrix. If we are measuring the length or downstreamness, we can make it the identity matrix. We can see that this is quite familiar, right? And next page, please. And on the next page, we are trying to measure the two-dimensional risk, which measures the risk or steps between each starting state and the absorbing state. Here we can see that in using these indicators, we are trying to measure what is the risk of starting from the state as I and absorbed by a given state as A. And the indicator is here. And using these, we can know the length between each pair of industries, like from coal mining to vehicle, like from iron or steel to ICT industry. This is actually the APL measurement. And next page, please. Yeah, this page. And also, as we have learned from Satoshi and Hanaka, we know that the passing through rules is also quite important. So this is related to the higher dimensional risk. So to answer this, we are trying to understand what is the risk of starting from state as I and absorbed by state as A of passing through a certain route as J to as L. So here we can know the risks originating from certain routes, and we can also know that how certain route adds production length to a pair of industries. And next page, please. And using these indicators, we have obtained some preliminary results. For instance, we measured the passing through frequencies of various countries and industries. And here we measure how each country sector's total expected risks are formulated by passing through various production stages. And here we are setting gamma equals to 1. That means the risks fully accumulates along the global supply chain, and the frequencies fully accumulates along the global supply chains. And to simplify the figure, we classify risks into 3 categories from the starting country sector, from different sectors within the same country, and from foreign sectors, from foreign countries. And the major findings is that the countries with the highest total expected risk are concentrated in developing economies, for instance, China, India, Indonesia, and Vietnam. And next page, please. And we also measured the risk for each country sector starting absorbing pair. That means here are the origin of the country and industries, and here are the destination or the final products of industries and countries. And here are the top 100 risky pairs in the input-output systems. And how risks are linked to the starting state of the GVCs and absorbing state of the GVCs. And here the figure shows this. And the major finding is that the riskiest pairs are concentrated in some countries, like those GVCs originated from Australia, United States, China, and Russia, and those GVCs whose final products were absorbed in India, China, and the United States. And the GVCs starting from the mining sector is usually associated with higher risks. And also GVCs starting from mining sectors in Australia, Russia, Saudi Arabia, and rest of the world, which is a country in the IO table, and which are absorbed in many sectors in China and India, actually already account for a large share of the top 100 risky GVC pairs. Next page, please. So are the risks and lengths related, and does higher risks often related to longer GVCs? And we also plotted the 100 lengthy pairs in the matrix, and we find that higher risks are often related to longer GVCs. However, this is not an absolute answer. A large part of the top risky country sector pairs are among the top lengthy country sector pairs, of course. This is because more stages the production chains pass through, the higher the risks accumulate. However, some of the longest GVCs are not within the highest risks. Thus, the risk level of the GVC route is not only decided by its length, but also other factors like its own characteristics, specific countries, and routes it passes through. Next page, please. And we plot the distance and the frequencies and risks. We found that the results show a positive relationship between the GVC risks and length. But if we could reduce the value of gamma, that is to say, to control the penetration or accumulation of risks, GVC risks will not be increased as fast as the frequencies or lengths. Next page, please. We also want to know which countries have induced the most risks when GVC is passing through them. So here on the left, it shows the total risk of passing through any country, and on the right, it shows the total GVC start. We have the total GVC starting absorbing combinations. So here we have the average risks of GVC passing through any country. We can see that on the left, it is the risks of GVC passing through any country, and on the right is the frequencies of GVCs passing through each country is quite highly correlated, and we can see that China and Germany, Japan, and United States, and these are usually passed through by other countries, and these countries are also contribute a lot to the global supply chain risks. Next page, please. And here comes the final sections, and also the section that I like the most about this method. And the probability-based method can have a very highly consistency with upstreamness and downstreamness and other GVC measures. For instance, the upstreamness in Paul Entry's paper and the upstreamness proposed by Fali in 2012's paper. These two indicators can all be obtained using the absorbing Markov chain with reverse model, and we can obtain an equivalent measurement from these three methods approaches. Next page, please. And about the average propagation length developed by Disenbach, and we can see that we can also obtain a quite similar expression with their indicator, but the only difference is the denominator. And also next page, we show that the absorbing Markov chain model can be also used to measure the passing through frequency. And for instance, in Satoshi and Hanaka's paper, they have calculated the passing through frequency using these two indicators. And using the Markov chain model, we can also obtain the passing through frequency, and we can see that their measurement is here, and the measurement in my paper is expressed in this way. These indicators are also quite similar, and the only difference is the denominator and the J matrix, which containing for one for the diagonal element and zero otherwise. And now I think this is the end of today's talk. If we have any questions, please do raise them.
Okay, thank you, Meng, for the impressive talk. Yeah, I won't take your time, so the floor is open to all the questions. I will stop recording for the Q&A.